Welcome to solverfy.
For this question, they are wanting us to find the concentration of sodium hydroxide when it's used in a titration of an acid solution. So we're going to first use this first balanced equation to figure out our moles of elements in our acid. So they tell us that our sulfur dioxide volume is equal to 0.2 liters. They tell us that the temperature is equal to 19 degrees Celsius. I'm just going to add 273 Kelvin to this. So our temperature is going to be 292 Kelvin. They tell us that the pressure is equal to 745 millimeters of mercury. I'm just going to times this by 0.0013159 atmospheres per millimeter of mercury, just to get it into units of atmosphere. So our pressure is going to be 0.980 atmospheres. They tell us that the solution volume is equal to 500 milliliters. I'm just going to change this into liters, so just divide it by 1,000, so 0.5 liters. Alright, so for this question, we're going to be using PV is equal to nRT. We're wanting to find the number of moles, so that way we can find the concentration of our NaOH. So let's find the moles of our sulfur dioxide first. So we're going to be using our pressure, 0.980 atmospheres, times our volume, 0.2 liters. Divide that by our R value, which is 0.0821 liters, atmosphere per mole Kelvin. And then times that by our temperature, which is 292 Kelvin. So our moles of sulfur dioxide is equal to 0.008176 moles. So molarity is equal to the moles of solute over the volume of the solution. So we know that this is our number of moles of sulfur dioxide, so 0.08176 moles. And we know that our solution is 0.5 liters. So the molarity is equal to 0.0164 molar. Alright, so now let's find our moles of H2SO3, or our sulfurous acid. So we know that if we come up here to our molar ratio, we know that there is 1 mole of our acid to 1 mole of our sulfur dioxide. So let's take the moles of our sulfur dioxide, so 0.008176 moles, and times that by the molar ratio, so 1 mole H2SO3, divide that by 1 mole of the sulfur dioxide. So our moles of our sulfurous acid is equal to 0.008176 moles H2SO3. Alright, so now that we have our moles of our acid, we need to write out our balanced equation for our titration. Alright, so this is going to be our balanced equation. So we're going to have H2SO3, and this is going to be aqueous, plus 2 NaOH, and this is also going to be aqueous. And our products are going to be Na2SO3 aqueous plus 2H2O. and H2O will be liquid. So that's our balanced equation for the titration. So let's find our moles of NaOH. Alright, so we're going to take our moles of our sulfurous acid, so 0.008176 moles, and we see that for every mole of the acid we have 2 moles of NaOH. So we're going to take 2 moles NaOH, divide that by 1 mole of H2SO3. So our moles of NaOH is going to be 0.0164 moles of NaOH. Alright, and they tell us that the volume of NaOH to get the titration to its end is 10 milliliters. So we'll convert that into liters, so 0.01 liters, just divided by 1,000. So the molarity of NaOH is equal to 0.0164 moles divided by the volume, 0.0100 liters. So our molarity is equal to 1.64 molar NaOH. And this is how we solve for the concentration of NaOH.